everyone, so today we're going to talk about one of the classifications of noise, which is the correlated noise. In our previous video, napag-usapan na natin yung noise at nabanggit natin doon yung correlated noise. Pero sa video na to, mas pag-uusapan natin yung correlated noise in detail. So what is correlated noise? This noise is present when there is a signal. It is generated by nonlinear amplification and includes nonlinear distortion. So, dito sa correlated noise, no signal, no noise. Ay, kung walang signal, wala ding noise. Merong types ng correlated noise, which is the harmonic distortion and the intermodulation distortion. So, dito sa figure na to, makikita yung correlated noise. Sa figure A, makikita ang harmonic distortion. At sa figure B naman, makikita ang output frequency spectrum ng intermodulation distortion. Ayan. Harmonic distortion. Harmonic distortion occurs when unwanted harmonics of a signal are produced through nonlinear amplification. Amplitude distortion is another name for harmonic distortion. Now we have the total harmonic distortion. So, THD or total harmonic distortion is defined as the ratio of the equivalent root mean square or RMS voltage of all the harmonic frequencies from the second harmonic and so on over the RMS voltage of the fundamental frequency, or the fundamental frequency is the main frequency of the signal. So this is how we compute for the percent total harmonic distortion. So for the percent total harmonic distortion or percent THD, we have the formula V higher over V fundamental times 100. The V higher is equal to the quadratic sum of the RMS voltages of the harmonics above the fundamental frequency. Okay, so we have there, for example, to get the V higher, the formula is the square root of V sub 2 squared, V sub 3 squared, and V plus V sub n squared. So, kung ilan man yan, halimbawa, 5. So, halimbawa, 5 yung voltages na meron ka. So, to solve that, we use the square root of V sub 2 squared plus V sub 3 squared plus V sub 4 squared plus V sub 5 squared. So, yun yung gagamitin. So, and while the V fundamental is equal to the RMS voltage of the fundamental frequency. So, for the total harmonic distortion, this is an example problem. So, the question is, for letter A, the second, third, and 12th harmonic for a 1 kilohertz repetitive wave. And for B, the percent second order, third order, and total harmonic distortion for a fundamental frequency with an amplitude of 8 VRMS, a second harmonic amplitude of 0.2 VRMS, and a third harmonic amplitude of 0.1 VRMS. So for the solution for the A, harmonic frequencies are simply integer multiples of the fundamental frequency. So we're going to have for the second harmonic, 2 times fundamental, which is given there, 1 kilohertz, is equal to 2 kilohertz. And for the third harmonic, we have 3 times the fundamental, again, which is 1 kilohertz. So we have 3 kilohertz. And for the 12th harmonic, we have 12 times the fundamental, which is 1 kilohertz. So we have 12 kilohertz. Now, for the B, we're gonna find the percent. Okay, for the percent of the second order. So that percent second order is equal to V sub 2 over V sub 1 times 100. So we'll get 0.2, which is given there, over 8, which is the VRMS, or the fundamental frequency, times 100. So we have 2.5%. And for the percent third order, we have V sub 3 over V sub 1, which is a fundamental frequency. So we have times 100, which is 0.1 over 8 times 100, and we'll get 1.25%. And for the percent PHD, or the percent total harmonic distortion, we use the formula. So we use the square root of 0.2 squared plus 0.1 squared over 8, and that will be equal to 2.795%. Now, intermodulation distortion. Generation of unwanted sum and difference frequencies produced when two or more signals mix in a nonlinear device. The sum and difference frequencies are called cross products. So for cross products, you have F1 plus or minus F2. So F1 and F2 are fundamental frequencies where F1 is greater than F2, and M and M are positive integers between 1 and infinity. So for our example, for a nonlinear amplifier with two input frequencies, 3 kHz and 8 kHz, determine A, first 3 harmonics present in the output for each input frequency, and B, cross product frequencies produced for values M and N of 1 and 2. So for the solution for A, the first 3 harmonics include two original frequencies, which is 3 kHz and 8 kHz. 2 times each of the original frequencies will get 6 and 16, 6 kHz and 16 kHz, and 3 times of each original frequencies are 9 kHz and 24 kHz, because ang hinahanap natin dito ay first 3 harmonics present in the output of each input frequency. Now, let's go to letter B, cross product frequencies produced for values M and N of 1 and 2. Again, ang formula natin dito for cross products ay NF1 plus or minus NF2, in which F1 is greater than F2. So let's see. So as you can see in our solution, in the equation, you can see the M and the N. So we do the cross product. So if M is 1 and M is 1, we get 1 times 8, so 8, and then 1 times 3, so 8 kHz plus 3 kHz, we get 11 kHz, and 8 kHz minus 3 kHz, we get 5 kHz, so their cross products is 5 kHz and 11 kHz. Now, for the second line, where the M is 1 and the N is 2, 1 times 8 is 8, 2 times 3 is 6, so 8 plus 6, we get 14, so 14 kHz, and 8 minus 6, we get 2, so 2 kHz, so the cross products will be 2 kHz and 14 kHz. Now for the third line, where the M is 2 and the N is 1, so 2 times the base, which is 8, so we get 16, and then 1 times 3, we get 3, 16 plus 3, we get 19 kHz, and 16 minus 3, we get 13 kHz, so we get 13 kilohertz and 19 kilohertz as cross products. Now for the fourth line where the M is 2 and the N is 2, we get 2 times 8, we get 16. 2 times 3, we get 6. 16 plus 6, we get 22. And 16 minus 6, we get 10. So for the cross products, we'll get 10 kilohertz and 22 kilohertz. That's all for our lesson about correlated noise. Thank you for listening.